Awesome. Oh my word. Hello all. So firstly, on behalf of, I suppose, BT Group, I should probably tick that corporate box and say thank you everyone for coming along to ARPAS' AGM. I'm really glad that we could contribute and host you here. So what I was planning on talking about today is, funnily enough, this stuff. When I say I mean Ed, who sat there. But before doing that, I just want to give you a little bit of an intro into what we're doing as I suppose, BT Group in this space. If this works, go click and hope for the best. Have I gone too far away? I am.
Next slide, please.
Just like that. So I'm that. Dave Pankhurst, I run BT's drones team. So super quick intro. I've been in BT for about 7 years, running BT's drone team for the last 5. In BT, we started off with about 2-ish people. We're now up to about 20, building out products and services for the future in the drone industry. Across BT, there's growing up to about 20 pilots that we have across the business now, who, funnily enough, do things around infrastructure inspection, rooftop inspection, that kind of stuff for our own purposes. So we're an active drone operator, which is obviously why being part of this community is really beneficial to us. If this works, let's pretend. Obviously, I'm sure that the majority of people in the room know BT to some extent. Obviously, huge brand, huge customer base, lots of services that we bring. But one of the risks of an organisation that has built very established, trusted, credible services is you can get a bit stale and not potentially think about what's happening next. What are our customers doing? Where does the country need to go? And how can we support with that? And so one of the things that we're really keen on is trying to go, okay, what are those new industries and where can we be relevant and support that going forward? I sit in a part of the organisation that's called etc. And etc. is really thinking about those next big things and where can BT support and create value for the community. In it, we do this whole great Amplify Invest thing, and I sit alongside colleagues in fintech, health, factory, where you may have seen we've done some stuff in EV charging and drones, which is funnily enough why we're all here today. And I suppose for us, we look at it through the lens of where can we be relevant? Where can we support the industry? And naturally, as the industry grows and develops, more digital services, connectivity services, infrastructure requirements start to come through, which is more and more relevant for a telecommunications company to help and support the industry. And for us, the services that we're looking at are roughly across this space. So connectivity, which I won't go into too much detail because I'll steal all of Ed's glorious thunder, is definitely about how can we help drones become more connected, enable more things to happen. How do we think also, though, about the hardware and the infrastructure that's needed to support that? How can we think about the insights that are going to be required going forward, whether that be about coverage at altitude, whether it be about population density to support future risk assessments? What's the kind of information that we can provide and support to help contribute towards the industry growth? From a drone flight point of view, we invested in Altitude Angel last year. We've been supporting them in terms of their infrastructure rollout pieces around their Arrow technology, around future BVLOS. And you may have seen yesterday that we as BT have also started to take their Guardian software into the market as well, to try and find any ways we can to speed up the kind of application approval processes for operators to be able to get up in the sky and do the stuff that we need to do. We also, as a group, recognise, and it kind of came up in some of this morning's conversation, that we as BT, obviously, let's use the analogy of our broadband network. We want people to use the internet, but we also think about security. In the same way, we want loads of amazing drone flights to happen and everyone doing brilliant stuff. But we also need to think about what's the potential risks of drones in the airspace as well, where we have detection capability. But we also use that same stuff as an enabler for ground-based to detect and avoid. And then the last one really around drones on demand. So we are, as I sort of said, growing a pilot community within the business. How can we build that? create new digital services to support our infrastructure and all those kind of pieces. And we're also looking at technology, drone in the box, automated drone stations to complement that as well, where you might have repeatable uses on a site or in a region. So a whole host of stuff that we're doing, but all of this coming together to try and support the growth of the drone industry in the UK and create all the value that's in all of the reports that we've read. So that's enough for me, quite frankly. I'll hand over to Ed now, if this button works, who's then just going to take you through some of the stuff that we've been doing in the connectivity space.
Right, thank you very much. Hello, everybody. Yeah, so that works, but my laptop doesn't, and I have a terrible memory, so I need notes. So yeah, so I'm Ed Hunter, so I work for Dave in the etc. area of BT. I look after an area called Drone Connect, and that's predominantly, I guess, my sort of role is to support drone operators and OEMs with their sort of like connectivity journey, sort of how do we start to adopt cellular primarily at altitude, but then also how does that interleave with other communication technologies for command and control, payload, and all that other sort of good stuff. A little bit more about me. So I've been in R&D and innovation for sort of 10 plus years. This formatting's got really, really bad as well. So there's, sorry, I didn't mean to stare straight at you there, but yeah, in R&D and innovation for 10 plus years. I've been in telco for more than 7 years, and I've been starting my drone journey from the Innovate UK program accelerators, where I first started, I guess, my exposure to drones. So as well as supporting OEMs and drone operators, I also do a lot of sort of support in the regulation space. So we've done a lot of things with Ofcom and with the CAA over the past few years and weeks. So mobile networks as a BVLOS enabler. So that's what we're here to talk to you about today. And I thought it was a good idea to try and define this, and hopefully my definition is somewhere in the right ballpark. Otherwise, it's going to be a really, really sort of dangerous next 10 minutes in terms of what I've prepared. So I've characterized this as something that allows an operator to fly their UAS further for longer and safer than you can under visual line of sight conditions. So just really quick, succinct sort of synopsis of what I understand a BVLOS enabler to be. So you think of it in that context as a BVLOS enabler, the mobile phone network sort of off the shelf, you'd think, well, that's a pretty good proposition, right? It's got national coverage, got some stats here. So I think as EE network anyway, we have 87% geographic coverage across the UK. So being able to fly further and longer than you can under VLOS conditions. Low latency data links. So we have millisecond latency, which is great for safety right across the UK. 24/7 availability. There's people in our technical operations centres and network operations centres 24/7, make sure the network's on. We have the operational framework to make sure the network's upgraded, kept sort of to its best, sort of most secure capability, and always on, always operating it should be. And it's super secure. So we have quantum level encryption between the SIM card and the network, which is of course like another great safety feature. So you'd think as an enabler for BVLOS, allowing someone to fly slightly further for longer, a bit safer, it's pretty good, right? So that is until you mention a couple of sort of key words which might resonate maybe with some people in this room. The first one might be this one. The second word is Ofcom, and the third word there, Civil Aviation Authority. So there's a bit of, I guess, nuance, I guess, between drones and sort of your traditional mobile phone user, which I guess strikes a different chord with each one of these sort of user groups. So I'm going to step through each one and hopefully go into a bit more detail there. So drone, what's different to a mobile network operator from a drone to a mobile phone? So hopefully most of the time they're in the sky and not on the ground, because that's what they're designed to do. And the term sort of coverage, once you're at altitude, takes on a completely different meaning. So I do all my own diagrams. They're available as t-shirts afterwards. If anyone wants them, they'll get better as the presentation goes on. So the drone there itself, you can see it's got line of sight now to so many more cell sites, so many more network assets. The solid lines there represent sort of its serving cell, but then all the dotted lines of that device's neighbor cell. So mobile phone at ground level tend to have maybe up to 5 extreme circumstances of serving cell and neighbor cell capability at any one time. With drones in the sky, we've seen numbers in the 70s sometimes. So particular areas, mostly in the urban areas, so drones at 400 feet or higher have much better line of sight, which you think, great coverage, got all the coverage in the world, that's amazing. CIA is going to be really happy. I've got all that network resiliency, but with more connections comes more noise. So coverage is never really a problem for us in the sky, although some of the drone operators like to find those really small areas where we can't provide it. So we also have, not looking up because some of them are in this room. So coverage takes on a new meaning. So it's not all about coverage. It's about that sort of the better redundancy, yes, but the noise implementation. So we as a network provider have to implement sort of upload and download noise handling capabilities to make sure that that sort of connection stays good. So the drone itself isn't having to decide and make these decisions between which cell is going to serve it the best from a list of 1 to 70. It's confined that list much further down. So it's not sort of doing all that sort of tricky computation at any one time, and it's only listening to the best possible cells at any one time. We also do a lot around network prioritization as well. So if the drone does connect to what it deems to be the best serving cell, but that cell's in congestion from a sporting event or a busy railway station, any of those sort of reasons, we can sort of ensure that that drone's got the best possible connection, is going to remain connected and have the best possible chance of success whilst in the sky. I've got a really, I guess, slightly boring sort of anecdote here as well about cell sites and SIM card read-write cycles. So the drone SIM technology as well that we've implemented in October last year, we decided to build that on IoT style hardware. And we'll go into some of those benefits a bit later, but one of them is an interesting anecdote from Eddie Stobart. So Eddie Stobart lorries up and down the motorway all day, every day, loads and loads of, every time the drone or the mobile phone has to make a decision about what cell site to attach to, it goes through a read-write cycle. Your SIM card on your phone has an enormous amount of read-write cycle capability, but not enough for something that's constantly in motion and constantly moving. So after 2, 3, 4 years, you build up the read-write memory of the SIM card. So the IoT M2M style SIM cards have sort of things like 10 or 15-fold sort of read-write cycle capability. So Eddie Stobart's lorries up and down the motorway over and over and over again. Gradually, they started to fall off the network, and it took forever for us as a network operator and others to realize why. And it was the SIM card and actually the physical memory that lives within the SIM card. And we as a network operator had never seen that before. It's a good 5, 6 years ago that now, so I could talk about it. But yeah, that's the sort of like problems that we have to think about as well within the drone context. The next thing as well is the environment. So rather than being in a nice sort of room temperature pocket in your jeans, the drone is now sort of outside in the elements. So it also has the option of taking off from the nice warm ground and transitioning up to something that might be sort of very cold. The moisture in the air might change, the humidity levels might change, and also that drone is vibrating at quite a rate. So again, another reason why we sort of looked at IoT and M2M style hardware is for that much more ruggedized, much more outdoor capable SIM technology versus what you'd get in your mobile phone in your pocket. This is I'm very proud of the pictures on this one. So finally, from a network operator's perspective, why are drones so different? So cellular capability. We've seen a lot of inconsistency is what I've written here, but that's being polite in terms of what people deem to be cellular capability. We've seen all manner of antennas, drones coming from the America regions trying to work over here in the UK and wondering why they don't work. They're not configured to work here. They don't operate on the same spectrum bands. We've seen drones claiming 5G capability when they're not even hitting the sort of the standards and KPIs for 3G. So there's a lot that I guess happens to even get to the point of calling yourself cellular capable. And that's why I guess us as a network operator, we want to be certifying these devices and making sure that when they connect to the network, they are hitting those KPIs and hitting those standards that we'd expect to see from any other device. We do it for Apple, Samsung, any device that comes out to market in the mobile phone world. So we should absolutely be doing the same for drones. Why do Ofcom care as well in this for drones? So spectrum management. So Ofcom's primary role is to make sure that spectrum is managed correctly and everyone has their own space to operate in. The spectrum that you've bought is a spectrum that you could use, and there's no conflicts there. So we're seeing a sort of a coming together of industries here and sort of the aggregation of multiple technologies. So not only are sort of mobile phone operators having to work together somewhat to provide coverage, so multi-SIM coverage capabilities to drones, but also the blending of ground-based C-band, satellite L-band, and cellular all together in the same arena. So having to manage that spectrum on the ground and transitioning up to the sky is a completely different problem to solve. Again, so as we spoke about before, having the drone elevated, sort of having better line of sight to more radio towers and more sort of coverage capabilities can really change the dynamics of the network. So we did a lot of work with Ofcom at the start of last year to quantify what good looks like, I guess, from a cellular perspective at altitude. And that led to them releasing the Ofcom framework. So Ofcom also care about licensing, and a lot of people in this room probably know, but if you don't, there is a specific license that you need to fly your drone over cellular at altitude. And there's also some conditions to that license as well, where you have to get your permission from the mobile network operator. So we've done a bit of work on that as well, writing that into our T's and C's for any sort of drone specific plans and offerings that we bring to market. But also you have to block band 7. And this sort of language starts to become a bit difficult for drone operators, I guess, because what does band 7 mean? What does 2600 mean? How do I block that? How do I log into my drone, tell it to not use a particular frequency? And again, this comes back to the certification perspective of like, well, we can do that for you because that's our role. We're the network operator. We'll make that drone behave in the way that's appropriate for the environment it's working in. So Ofcom have put that stipulation on the drone operator, so the license holder, but we see it as our role to sort of make sure the drone operators are behaving within the confines of their license. Right, what's important to the CAA? Safety, of course. So what are the pros and cons of various technologies? So a single cellular connection, cellular and satellite connection, cellular, C-band and satellite, whatever that might be. How do you quantify the risk profile associated to aggregating those technologies? How do you marry up? Is C-band and cellular good enough if you're flying over 5,000 people, 10,000 people in a city, in the countryside? Like, what does that really mean? How do you sort of quantify, how the technology marries up with a risk score? And that's something that we're going to have to take on. We have the data for that. The CAA don't. So we really have to work together with the regulator to put those risk categories next to the appropriate technologies, get them certified, get some agreement so that everyone's really working off the same page. Because again, that's a really difficult problem for drone operators to have to tackle themselves. So we've got the data, we've got the insights, we need to find a way of getting that into the right people's hands. And I guess building on from that, so it's about providing the data in a clear, meaningful manner, providing the insights, and again, associating those technologies with the right risk categories, and even providing tools to allow the CAA, the regulator, to be able to interrogate our network and other networks and the network technologies and population data, all those other good things to be able to review and, I guess, again, assign specific risk categories and risk levels to a particular submission that they receive. So it's about us exposing our data and our tools and our capabilities to the CAA to allow them to do their job in the new world. So lastly, our role, not lastly, I'll say that. So our role as an enabler. I think it's really key that as a network operator, as BT, as Voda, as 3, whoever it is, the mobile network operator's role is to provide simple, certified and trusted solutions. So depending in the new world of SORA, what your sale category is or what sale category risk score that you've been assigned, there should be a set of technology there available that you could get off the shelf that's certified, ready to use, simple. You get one bill at the end of each month. You're not talking to 5 or 6 different vendors, very clear cut. You know exactly where you stand each time. So it's not your job as operators to know how the data gets from A to B, it's ours. And really you shouldn't give a monkeys how the data got there, whether it decides to go over cellular or satellite or any other sort of technology for that particular path. It should just work. It should be entirely agnostic and transparent. You tell the drone to return to home, it returns to home. You don't care how it did it, it just did it. and it works every time. Talked a lot about certification of technology, but I do think that's really, really important. So yeah, alignment with CAA framework to technology and making sure that's very, very clear. And we need to remove all those problems for you, make things simple. We handle the sort of the discussions and the low-level data with the CAA and empower operators with the tools to be able to make those decisions and sort of education to be able to have those productive conversations with the CAA as well. So we started building some connectivity predictive capabilities, some population prediction capabilities, and we've already started certifying some devices as well. And we brought our drone sim product to market as well last year. So we are really laying the foundations for supporting industry and you guys the best way we possibly can. So also we're, I guess, beyond an enabler is how I've titled the slide, but there are things that we can do and things that we're investigating around accurate positioning. We know that GNSS sort of validation, verification to the CAA is very important, and using our network to be able to say, yes, that drone is there, like it says it's saying it's there. Talked about alignment SORA a lot here and device certification quite a lot here, but we've also worked tons with BSI, 3GPP, GSMA, Civil Aviation Authority, BSI, and Ofcom to really ensure that we have these standards, that they're global and that they can be scalable as well. We're also heavily involved in the 5G standalone space, and we've also spoken a little bit today with a few of you about 6G as well, and some of the benefits that can bring in terms of network slicing and all other fun stuff that's on the horizon. I did want to just quickly touch on something as well, because BVLOS is obviously the buzzword of the moment, but there's a huge industry that's built around visual line of sight missions, and there's tons and tons of work and propositions and technology that we've been working on in that space as well. I think a lot of what we talk about in terms of the data resiliency and the integrity of our network is huge to the visual line of sight inspection industry, response industry as well, because the first time mission success is a really, really key thing. Interactive inspection, sending less people to site, so people aren't looking over people's shoulders, not having to wait until the drone's back on the ground, you've taken the SD card out, loaded the media, all that sort of stuff, and having that data resiliency as well. So if you're taking photos or taking media, they're straight up to the cloud. It's all backed up, it's ready to go. People are interrogating them straight away. But the first time mission success is a key one for us. So you're not having to return to site, not having to rerun flights. You go out, you fly that drone once, and you get everything you need to. So it's not coming back to home when the connection drops. It's not going AWOL. You're not having to deploy 5 or 6 people with different controllers to make sure that the connection always stays up. It's one pilot, one drone, first time mission success. And that's the lot. Thank you very much.
Thank you for that. Just a quick question on licensing.
Yes.
So if today you were to use RTK, okay, as part of the drone data capture, the SIM card and everything is in the controller on the ground,
Yep.
not in the air. Do you need a license or not?
No. So Ofcom's definition of something that's airborne is just not touching the ground. So you can be using your phone up here merrily, but as soon as you step out the window, then you're off the ground and you need a new license.
One thing I've not been able to bottom out, is there a specific criminal effect if you don't obtain that Ofcom license? Because I'm not aware there is. That's always the what if question. So what if you don't get the Ofcom license?
The answer is yes, it is a criminal offence. The likelihood of someone arriving at your door, maybe a bit negligible, probably shouldn't say that in front of Dave, but yeah, there's it is a criminal offence to be operating outside of your, I guess, you're given license, and it's also, you're breaking your terms with us as well at that point, so we have the right to cut you off and I guess seek remuneration as well, I guess, for not using our network properly.
In EASA, they're looking at 3 forms of conspicuity: ADS-B, ADSL, or 5G or mobile telephony. Are you looking at that as well in some capacity? Are you lobbying? Are you trying to provide evidence that it could be used in the UK?
Yeah, so we've ran some 978 ADS-B trials already over in Bentwaters with UAvionics and Skylift last year. So yeah, we're trying to build the ecosystem, but it all comes together, right? So the CA also been talking a lot about TISB and sort of the airspace picture, and it all forms part of the same ecosystem. The drone needs to declare its position, but it also needs to, other airspace users need to know the position of that drone as well. So it's almost two-way in that regard.
Okay, we'll do, so those, no, it's okay. One or two more questions, and then you have a couple on the Slido, but then we'll share them offline. Go ahead.
You mentioned there was one bullet point on position. Could you expand on that? Because obviously you've got multiple points. You could triangulate. Could that in-feed to detect and deployed? Could it in-feed to unmanned traffic?
So it's more about, I guess, the RTK and the sort of the position of that drone executing that mission. So we have 19,000 cell sites in the UK. If we could put a known GPS location on all those and rebroadcast it, your positioning would be fantastic right across the country. So that's what we're going after. Yeah, it's that's why it's on the future slide, because we haven't really quite bottomed that one out yet. But there is, sorry, and to build on that, 5G, 6G, you'll be able to do that from the network itself as well. Yeah. Yeah. By who?
Certify altitude positioning.
Oh, so has it been validated and tested? I guess so it was on the futures, like the things that we can look to provide. So yeah, we haven't, it's there, it's a possibility. We have all these locations, we have the capability to do it. So why wouldn't we?
All good.
Yeah.
Well, thank you very much, Ed and Dave. Thank you very much. We learned a lot.